congratulations on landing a great job as a commercial apprentice. It's understandable that you have been looking for a change, and it's wonderful that you have found a new opportunity to learn and grow. Thank you for acknowledging and appreciating the support and encouragement you have received from the community members here. We are always happy to assist and educate our members, and it's rewarding to know that our efforts have contributed to your success. I'm sure you will excel in your new role, and we wish you all the best in your journey towards ruling the universe. Please keep us updated on your progress, and don't hesitate to reach out if you have any questions or need any assistance. As for the car search, hopefully a suitable and affordable vehicle will be found soon. Safe travels on the new adventure. Electrical apprenticeships offer a structured path to becoming a qualified electrician. They combine on-the-job training with classroom instruction, providing a comprehensive understanding of electrical systems and safety practices. The duration of an apprenticeship typically ranges from 3 to 5 years, depending on the specific program and the complexity of the electrical work involved. During an apprenticeship, individuals learn to install, maintain, and repair electrical systems in residential, commercial, and industrial settings. This includes wiring buildings, installing lighting fixtures, troubleshooting electrical problems, and adhering to safety codes and regulations. Apprentices work under the supervision of experienced electricians, gradually increasing their responsibilities as they gain knowledge and skills. The classroom component of an apprenticeship covers electrical theory, blueprint reading, electrical codes, and safety procedures. Apprentices learn about different types of electrical circuits, wiring methods, and equipment, as well as how to interpret technical drawings and specifications. They also study the National Electrical Code, which provides guidelines for safe electrical installations. Safety is a critical aspect of electrical work, and apprentices receive extensive training in hazard recognition, lockout tagout procedures, and personal protective equipment. They learn how to work safely around electricity, avoid electrical shocks and burns, and prevent fires and explosions. Apprentices also learn about the importance of following safety regulations and using appropriate tools and equipment. To become a licensed electrician, apprentices must complete their apprenticeship program and pass a licensing exam. The exam tests their knowledge of electrical theory, codes, and practices, as well as their ability to apply this knowledge to real-world situations. Once licensed, electricians can work independently or as part of a team, providing electrical services to a variety of clients. Continuing education is essential for licensed electricians to stay up to date with the latest technologies, codes, and safety standards. Many electricians participate in ongoing training programs to enhance their skills and knowledge, and to maintain their licenses. There are many different types of electrical work, including residential, commercial, industrial, and low voltage. Residential electricians work on electrical systems in homes and apartments, installing wiring, outlets, and lighting fixtures. Commercial electricians work on electrical systems in businesses, schools, and hospitals, installing and maintaining complex electrical systems. Industrial electricians work on electrical systems in factories and manufacturing plants, installing and repairing heavy machinery and equipment. Low-voltage electricians work on low-voltage systems such as security systems, telephone systems, and data networks. Some common tasks in commercial electrical work include installing and maintaining lighting systems, which involve selecting the appropriate fixtures, wiring them correctly, and ensuring they meet energy efficiency standards. This can range from simple fluorescent lighting to advanced LED systems with complex control mechanisms. Another task is installing and maintaining power distribution systems. These systems distribute electrical power throughout a building, ensuring that all equipment and appliances receive the necessary voltage and current. This involves installing electrical panels, circuit breakers, and wiring, as well as ensuring that the system is properly grounded and protected from overloads and short circuits. Installing and maintaining control systems is also common. Control systems are used to automate and regulate various building functions, such as lighting, heating, and cooling. This involves installing sensors, controllers, and wiring, as well as programming the system to operate according to specific parameters. Another task is troubleshooting electrical problems. This involves using diagnostic tools to identify and resolve electrical issues, such as faulty wiring, malfunctioning equipment, and power outages. Electricians must be able to read and interpret electrical diagrams and schematics, as well as use their knowledge of electrical theory to diagnose and repair problems. Ensuring compliance with electrical codes is crucial. Commercial electrical work must comply with local and national electrical codes, such as the National Electrical Code. These codes set standards for the safe installation and operation of electrical systems, and electricians must be familiar with them to ensure that their work meets all requirements. This involves obtaining permits, conducting inspections, and documenting all work to ensure compliance. Commercial electricians also install and maintain backup power systems, which are used to provide power during power outages. These systems can include generators, uninterruptible power supplies, and battery backup systems. Electricians must be able to install, test, and maintain these systems to ensure that they are ready to operate when needed. They also install and maintain fire alarm systems, which are used to detect and alert building occupants to fires. This involves installing smoke detectors, heat detectors, and alarm panels, as well as testing and maintaining the system to ensure that it is functioning properly. Electricians must be familiar with fire alarm codes and standards, and they must work closely with fire departments and building inspectors to ensure that the system meets all requirements. Maintaining electrical equipment involves performing routine maintenance on electrical equipment, such as motors, transformers, and switchgear. This involves inspecting the equipment for wear and tear, cleaning and lubricating components, and testing the equipment to ensure that it is operating properly. Electricians must be able to identify and repair any problems that are found during maintenance. In commercial settings, there are often specialized electrical systems to work on. Examples include specialized equipment wiring, like that for HVAC systems, which often requires knowledge of motor controls, variable frequency drives, and other specialized components. Electricians must be able to install and maintain this equipment, as well as troubleshoot any problems that may arise. Another example is data and communication wiring, involving installing and maintaining data and communication wiring, such as Ethernet cables, fiber optic cables, and telephone lines. Electricians must be able to terminate and test these cables, as well as troubleshoot any problems that may arise. They must also be familiar with data and communication standards and protocols. Safety is paramount in commercial electrical work. Working with electricity can be dangerous, and electricians must take precautions to protect themselves and others from harm. This includes wearing appropriate personal protective equipment such as gloves, safety glasses, and hard hats, as well as following lockout-tagout procedures to prevent accidental energization of equipment. Electricians must also be trained in first aid and CPR, and they must know how to respond to electrical emergencies. To excel as a commercial apprentice, focus on several key areas. Firstly, prioritize safety by always adhering to safety protocols and guidelines. This includes wearing appropriate personal protective equipment, following lockout-tagout procedures, and being aware of potential hazards. Secondly, develop a strong understanding of electrical theory by studying electrical principles, circuit analysis, and the operation of electrical components. This will provide a solid foundation for troubleshooting and problem solving. Thirdly, become proficient in reading and interpreting blueprints by learning to read electrical diagrams, schematics, and architectural plans. This will enable you to understand the layout of electrical systems and the location of components. Fourthly, master the use of tools and equipment by becoming familiar with the tools and equipment used in electrical work, such as multimeters, wire strippers, and conduit benders. Practice using these tools safely and efficiently. Fifthly, familiarize yourself with the National Electrical Code. Study the NEC and other relevant codes and standards. This will ensure that your work complies with safety regulations and industry best practices. Sixthly, hone your troubleshooting skills by learning to diagnose and repair electrical problems using logical reasoning and diagnostic tools. Practice troubleshooting on a variety of electrical systems. Seventhly, seek mentorship from experienced electricians who can provide guidance, advice, and support. Learn from their experience and ask questions to expand your knowledge. Eighthly, practice effective communication by developing strong communication skills to interact with coworkers, supervisors, and clients. Be able to clearly explain technical concepts and provide updates on project progress. Ninthly, be detail-oriented in your work by paying attention to detail and ensuring that all tasks are completed accurately and thoroughly. Double-check your work to minimize errors and ensure quality. Tenthly, cultivate a proactive attitude by taking initiative and seeking out opportunities to learn and improve your skills. Be willing to tackle new challenges and take on additional responsibilities. 11thly, embrace continuous learning by staying up to date with the latest technologies, codes, and practices in the electrical industry. Attend training courses, read industry publications, and participate in professional development activities. 12thly, document your work by keeping accurate records of all work performed, including materials used, time spent, and any problems encountered. This will help with future troubleshooting and maintenance. 13thly, develop time management skills by learning to prioritize tasks, manage your time effectively, and meet deadlines. This will help you to stay on schedule and ensure that projects are completed on time. Lastly, cultivate a professional attitude by maintaining a positive attitude, being respectful of others, and representing your company in a professional manner. This will help you to build strong relationships and advance your career. In the 2017 NEC, there are several articles that are particularly relevant to commercial electrical work. Article 210.8, Ground Fault Circuit Interrupter Protection for Personnel, covers the requirements for ground fault circuit interrupter protection in dwelling units, guest rooms, and certain other locations. This article specifies where GFCI protection is required to protect people from electric shock hazards. Article 210.12, Arc Fault Circuit Interrupter Protection, covers the requirements for arc fault circuit interrupter protection in dwelling units. ASIs are designed to protect against fires caused by arcing faults in electrical wiring. Article 215, Feeders, covers the requirements for feeder circuits, which are the circuits that carry power from the service equipment to branch circuit panels. This article includes requirements for conductor sizing, overcurrent protection, and grounding. Article 220, Branch circuit, feeder, and service calculations, provides the methods for calculating the ampacity of branch circuits, feeders, and service conductors. This article is essential for ensuring that electrical systems are properly sized and protected. Article 230, Services, covers the requirements for electrical services, which are the conductors and equipment that deliver power from the utility company to the building. This article includes requirements for service entrance conductors, overcurrent protection, and grounding. Article 250, Grounding and Bonding, covers the requirements for grounding and bonding electrical systems. Grounding and bonding are essential for safety and for preventing electrical shock hazards. Article 300, Wiring Methods, covers the general requirements for wiring methods, including the types of wiring methods that are permitted in different locations. Article 310, Conductors for General Wiring, covers the requirements for conductors used in general wiring, including conductor sizing, insulation types, and ampacity ratings. Table 310.15b16 is a table within Article 310 that lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and in raceways or cables. This table is used to determine the correct size of conductors for different applications. Article 408, Switchboards and Panel Boards, covers the requirements for switchboards and panel boards, which are used to distribute electrical power to branch circuits. This article includes requirements for overcurrent protection, grounding, and labeling. Article 430, Motors, Motor Circuits, and Controllers, covers the requirements for motors, motor circuits, and motor controllers. This article includes requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. Article 440, Air Conditioning and Refrigeration Equipment, covers the requirements for air conditioning and refrigeration equipment. This article includes requirements for disconnecting means overcurrent protection and grounding. Article 500, Hazardous Classified Locations, covers the requirements for electrical equipment installed in hazardous locations, such as areas where flammable gases or vapors are present. This article includes requirements for explosion-proof equipment and intrinsically safe circuits. Article 517, Healthcare Facilities, covers the requirements for electrical systems in healthcare facilities such as hospitals and nursing homes. This article includes requirements for essential electrical systems, critical care areas, and patient care areas. The NEC is updated every 3 years, so it is important to stay up to date with the latest edition. The NEC is available for purchase from the National Fire Protection Association and other organizations. The NEC can also be accessed online through various subscription services.